Welcome. You're listening to Coffee Break with Purdue Engineering, a podcast production from the Office of Future Engineers at Purdue University. In this podcast series, we discuss the many programs, majors, and opportunities found in Purdue Engineering through conversational interviews with staff, faculty, alumni, and current students. We hope you enjoy our show and it helps answer some of your questions about what it's like to be an engineering student at Purdue. All right, welcome to this week's episode of Coffee Break with Purdue Engineering. Thank you for being here, Kay. We'll have you introduce yourself in a sec. Sure. But first, we're going to start with a discussion about a notable Purdue alumni.
Yeah, so today we're actually going to be discussing about an ME professor that goes by the name Julien Rouen, and he runs a research lab on Purdue's campus that created the world's whitest paint in 2020. And have you heard of him before, or?
So seeing as they have his picture on the side of the building that is next to my parking garage, yes, I actually park right next to his face every single day.
Oh, that's awesome. So essentially from what paint could reflect before was 95.5% of sunlight, and today they've actually created the closest opposite to Vanta Black, with their white paint being able to reflect up to 98.1%, and it sends infrared heat away from a surface at the same time. And
now, I think you've done a little research on the chemistry of it. I don't think it'll mean anything to me, but maybe someone's going to be interested in hearing about it.
Yeah, so it is so white because of the very high concentration of barium sulfate, as well as the barium sulfate particles being different sizes, which allows it to scatter more of the light spectrum. And the paint has efficiency applications for buildings and cooling systems, as well as potentially cars and airplanes.
Cool.
A lot of interesting stuff.
Yeah, I think last I heard they were trying to get it commercialized so that it was actually going to be used on a whole bunch of things, that's just really cool that it's coming right out of Purdue University.
Yeah.
Direct application of our research.
Absolutely. I think that Purdue does a really good job of advertising some of the more publicly accessible and applicable research that happens here. And thankfully in engineering, that's a lot of the work that happens. But there's also a lot of stuff that the public don't hear about. And that's one of my favorite things, is actually learning something new about the research that's happening in the labs here on campus. One of my favorite parts of my job.
Yeah, that's awesome. I'm sure we're going to get to talk about it in just a few minutes. But let's start this week's episode. So just in case you guys didn't know, I'm Calvin Given. I'm currently a senior in electrical engineering, and I'm from Lakewood, Colorado, and I'm planning to continue on into the 4+1 master's program. So I'll get my master's degree after graduating this December.
Congratulations.
Thank you.
Early congratulations.
Yeah.
Yeah.
And my name is Bryan Akinmade. I'm a current sophomore in electrical engineering from Miami, Florida. And on campus, I'm involved in NESB, MEP. I'm actually a residential assistant in the dorms, and I'm a member of Kappa Alpha Psi Fraternity Incorporated. And this week, we are joined by Dr. Kay Kobak, the Associate Director of EURO, the Engineering Undergraduate Resource Office.
Thanks for having me today, guys.
Of course.
Yes, my name is Kay Kobak. I generally ask people to call me either Kay, Dr. Kay, or Dr. Kobak. Happy for you guys to call me whichever one makes you the most comfortable. I am the Associate Director of the Engineering Undergraduate Research Office. We throw around way too many acronyms here on Purdue's campus. So yes, EURO is the generally preferred way of saying it.
All right, excellent. So do we want to start with some questions for you?
Certainly.
All right, let's start with the first one. What exactly is the Engineering Undergraduate Research Office, and what are its goals and missions? Why do you guys exist?
Oh, thank you. Glad to justify my existence. So EURO is aimed at helping either every engineering student get involved with research, or in the opposite, any student get involved in engineering research. We try to have as broad of a reach as we possibly can. We've actually got a lot of different stakeholders that we're engaging with and people that are utilizing our programs. During the summer, we have an even broader reach, and we look at all of STEM and trying to make sure that people are getting that opportunity to get their hands on in a research context. So the idea here is it's something called experiential education and experiential learning. We want students to be able to apply what it is that they're learning in their classes and actually have experience of what it means to utilize that in real life and what is a job, what a career would utilize that as. So we are looking not only at those who are new to research and trying to make sure they have those opportunities, but we also want to make it so those who are experienced in undergraduate research, have done some of this stuff before, they have opportunities to continue advancing as well as learning new things and digging deeper, and that opportunity for inquiry, really exploring what it is that is on the edge of human knowledge at a current point in time. So what we're looking to do really is making sure that every student has the opportunity to apply their knowledge. We would like everybody to try research, but really as long as you try something while you're in undergrad, I think that's what's most important. And then we want to make sure that we're supporting our researchers both in terms of their professional and academic development and thinking about what their future careers might be.
That's awesome.
Yeah, that's amazing.
Sounds like you definitely fully justified the existence.
I hope so.
Yeah.
I think with that, I'll kind of ask, how are students able to get involved with Euro through like the College of Engineering? And how are new students on campus able to get involved?
Right. So if students want to get involved in engineering research or research in general, they actually don't have to talk to us at all. We are a resource and we want to make it easier for people to engage with research, but you certainly do not have to take our classes, engage with our opportunities and all of those things. It's just so that we can make things a little bit easier. So the best way that I would say, if you never wanted to talk to us ever, to start engaging with research is actually to cold email faculty. So figure out who's doing work that you're interested in. All of this is stuff that is available on the Purdue Engineering website. You can look up who is doing research in what area, what their current publications are, what other students they're mentoring, this, that, and the other. And frequently on their websites, it'll say something like, if you want to get involved, either email me or apply through this Qualtrics, or don't contact me until after you've taken this class, or something to that effect. And so every faculty that has got research on campus has one of these websites. Now, they might be outdated. That does happen. But if you reach out to the faculty, you can learn about what they're doing and who they're willing to work with regularly. So there's lots of faculty that are super passionate about getting undergrads hands-on in their research from the very beginning. And so the earlier that a student gets involved in a lab, the better skills that student can develop over time. And so a lot of faculty like taking on first-year students because that gives them 4 years to work with that same person and make sure that they're really advancing in that project. So that's if you don't ever want to talk to us. You can do that and still be very successful in research.
That's the route I took.
Hey.
Yeah. I did research last spring, and I'm also doing research currently. I got involved with the one currently just by talking to the professor that I had for one of my classes last spring. He gave a lab tour at the end of the semester because he wanted to give us the opportunity to see what he was doing in research. And then that turned into, over the summer, I set up, okay, I'll do research for you and with you in the fall. And so that was a really cool opportunity. And in the spring, I was just browsing those professors' websites and looking for emails and ways to reach out to them. And that was also really cool. So you've definitely hit the ways.
So I would say that is actually the most common. It's also something that you can do not only at Purdue. You can do that anywhere. So one of the things that we offer during our office hours, so we actually keep our office staffed basically the entire work week, so that if a student walks in at any time, we've always got somebody on hand who can answer your questions about whether it be emailing faculty, finding faculty and the type of research that they do, how to get funded for your research so that you're either getting paid or that you're getting credit that is showing up on your transcript. If you are already actively doing research and you found something cool and you want to tell people about it, we'll talk to you about how to publish or how to present at a conference. So we offer a lot of consulting. I would say that that's actually the number one thing that we do, at least time intensity wise, but we also run a lot of programs to make it easier to get involved in on-campus research. Some of these are classes even. So I teach, Engineering 103. So it's called Intro to Research. And so this is essentially what in the world is research anyway? So talking about the different types of research that you can get involved with. How do you contact faculty? One of the assignments is actually to go meet with faculty, because for a lot of students, that's really scary.
It can be.
For sure.
Yeah.
Well, and then especially if you're talking with somebody that they are an recognized expert in their field. A lot of people have a hard time asking questions when they know that they are not the smart person about something in the room. But what I find is that faculty, anybody that is these experts, they recognize that they are the expert, and so they expect people to ask them questions. And so I always encourage students that there is no such thing as a stupid question when it comes to asking about research. The whole point is this person is the most intelligent about what it is that they are doing. Excuse me. They know something that you don't and that most of the rest of the world doesn't. That's totally normal. So anyway, that's one of the things that we talk about in Engineering 103. We also have our first-time researcher fellowship. So this is a spring semester program where we offer professional development, and we also help match students to labs that are specifically looking for those without prior experience. So it gives students that opportunity to get hands-on in lab without having to go through the whole cold email process, because like I said, sometimes that's scary.
And sometimes the professors don't respond.
Oh, goodness. Yeah, I would say that that's more common than
we'd like it to be.
Well, more common than not, honestly. I think that faculty are super, super busy, and that's to be expected. They wear a lot of hats. They teach classes. They run research labs. They're not just doing research and asking the question, but they're mentoring others who are doing research and asking deeper questions, too. So I think that a faculty's email inbox is a very scary place.
Yeah, I remember one of my friends before we even got to college, he was talking about how he was emailing one of the nuclear professors to try and do research, and he would respond like, "I'm not doing research with anybody this upcoming semester." And he would just keep asking him as time got on, and then as the school year started, the professor was like, "All right, you've asked me so much, I'm going to give you the opportunity," and ended up doing research. So it's his persistence, and that was really cool to see for him.
That is cool.
Yeah, I mean, I think it's worth saying that persistence is one of the biggest indicators of whether you'll be successful in research or not.
Yeah.
So that's one of the things that we talk about in our Engineering 103 class. Research is hard. You're going to be asking a question that nobody knows the answer to. And a lot of students, especially if you were really good at taking tests and getting good grades in high school where you just had to memorize and regurgitate, as soon as you step into the lab, suddenly the question you're asking doesn't have an answer. And so there isn't a right answer for you to regurgitate. And so therefore you're going to run into a lot of you're going to come up with a lot of things that are wrong until you figure out the right one. And that's hard for a lot of students right when they're first getting started in research.
Yep.
So persistence is super important.
Awesome. Now, I know you maybe briefly mentioned them, but you guys are in charge of the Surf and Stars program. What are those? What's the difference between the two? Because I believe they're both in the summer. And how do you decide which one you should do if you want to do one of them?
Right. So SURF is our big program. So what that stands for is Summer Undergraduate Research Fellowships. So we consider it an umbrella program. It is actually, how many now? We cover a large number of summer programs that actually fall under ours as the umbrella program. So what each of those individual programs do is they offer maybe different sets of benefits, different sets of professional development that you can take along the way. And then we make sure that all of them have sort of the same core set of activities. So we offer some professional development in terms of how to write a research CV. So a lot of people don't know that a CV is different from a resume. How do you put one of those together? How do you, manage your time in the lab? So quite frequently, a lot of students will see that they have a protocol, a list of instructions of how to perform an experiment, and they'll say, oh, okay, so that'll take 2 minutes, that'll take 2 minutes, that'll take 30 minutes, whatever. We always tell them, whatever you do, doesn't matter what the step is, it's going to take at least 5 minutes. You really need to overestimate. When I was first in grad school, there were certainly nights that I was like, oh yeah, this will take me maybe 2 hours, and I was there 5 hours later. Yeah. So figuring out how to manage your time while being a researcher is one of the things that we teach, but it's not just time management. It's all of the pieces and parts of how do you engage with your research well? How do you communicate your research out to other individuals? So there's lots of professional development that we offer, and that's why we actually encourage students to engage with our programs as opposed to only directly reaching out to faculty and cold emailing, so that we're providing some of that support structure along the way. So that's what SURF is. It's very specifically, it is a 10-week on-campus, full-time academic research internship. So you're going to be in lab, directly interfacing with faculty and graduate students, and performing inquiry-driven research, asking a new question and trying to figure out how to fill either that gap in terms of building something new or creating new knowledge. STARS, on the other hand, is a that is a technical skills development internship in semiconductors. So I told you earlier that acronyms are a big thing here at Purdue. So STARS is the Summer Training and Awareness and Readiness for Semiconductors. I help run the program, and I have a hard time remembering. So
we remember the acronyms so much more than we do what they actually stand for.
Oh, my goodness, yes. So STARS is intended to be for those who are early in their academic career, so probably the summer after your first year. And the goal is that we are getting you hands-on in the semiconductor space, learning what it means to be able to work in semiconductors and developing the skills so that the next summer you hopefully get a really high paying as well as prestigious internship in the semiconductor space at a company that regularly is hiring people there. So it's intended to be a pipeline program. We connect those students with industry leaders and industry professionals. We have talks from individuals in industry. Each student gets an industry mentor that is supposed to be helping them throughout the course of the next year or over the summer as they're thinking about what it is that is next. And so we even get students into the clean room. So the full bunny suits, everything is sterile, and making sure that you're actually getting your hands on equipment and techniques that cost thousands of dollars to be able to perform. And there's really not very much opportunity for early career undergraduate students to do that across the United States.
Well, that sounds awesome that Purdue has it to offer that.
Yeah, for sure. We're really proud of the program. I mean, Purdue talks about semiconductors a lot, but I think that there's a big passion here for getting students engaged early on so that they can build those skills out and become really technically proficient at what it is that they do. So then when they turn around and go into industry, they are already ready to perform and they can hit the ground running. And so that's the case both in SURF, where it's research and sort of that inquiry-driven space, but in STARS, where it's developing those hands-on techniques and skills in more of a training type atmosphere instead of asking new questions, but still exposing students to what that means to ask questions in the semiconductor space.
Got you. And I guess along with that, for undergraduate researchers, researching students, that what resources does Euro offer to them while they're doing their research?
Right. So I've mentioned a couple of these along the way. So when we have a travel grant, so we'll pay $500 towards your travel to go to a conference to talk about what it is that you have learned. So if you want to go to Hawaii, because there's a conference in Hawaii on your topic, we'll help you pay for that. We also know of the other offices on campus that will help pay for those things. And so we'll help you coordinate across the different locations that you can get funding. Because in my opinion, undergrads shouldn't have to pay to go to a research conference to present their work. They are benefiting the field, and so we want to make sure that you have that opportunity.
That's amazing.
We also offer computational resources. So a lot of the research that gets done on Purdue's campus, especially for someone in ECE, is computational. And so you're coding, you're building new platforms that do new things, and frequently your personal laptop does not have the computational power in order to do that. So we've actually got hardware that we loan out, so you can utilize that as sort of an extra computing source that is on hand with you at a given point in time. Or we also offer access to high-performance computing clusters on campus at no cost to the PI. That's the faculty that's the faculty mentor of the undergrad that's doing research. So the goal is we're getting you access to those resources that you can utilize to perform really high impactful research. But we also have office hours, and so I've said that too. We're actually just located right upstairs. But we have people on hand all week long to talk about all of these resources, as well as a number of other things that are available on campus to undergraduate researchers.
That's awesome. Yeah, and I know, just going back to one of the points you made earlier with STARS making people career ready, that's definitely just a common theme among anything Purdue engineering. And that's why we're such a prestigious and high-ranked university, I think, at least part of it, because it's the quality education and the actual technical skills to back it up and be able to have a competitive advantage against the other applicants.
Right. I think Purdue engineers and Purdue graduates in general, they have had the opportunity to have the experience. Mm-hmm. They're not just doing book learning and book knowledge. They're not just regurgitating information, but they've engaged with it, and they've engaged with it deeply. And so that, I think, is what gives students the competitive edge. Now, frequently for researchers, that competitive edge is actually in applying to graduate school. And we offer a lot of help with students in that space as well. So we review academic CVs, we review personal statements, not only for students applying to summer research programs, but to those who are thinking about pursuing research more long term. So grad school can either be more classes, or it can be primarily research focused. Mm-hmm. And so if you're doing the research route, you're going to also have classes, obviously. But that's what a PhD is it's saying that you have discovered or created something new that nobody else in the world has done before. And research gives you the opportunity to get to that stage. And when you do it, then they decide to call you doctor.
Yeah. Yep. I know one of my friends in biological engineering is actually going to graduate with multiple publications, and then she's going to continue on to her PhD. So the research track here has definitely helped her get into those programs.
Yeah, multiple publications is a really big deal for an undergrad. Mm-hmm. So I used to help with grad admissions at my previous institution, and I've also done some of the grad admissions that actually happens here at Purdue as well, in a different position that I was in before this one. But undergrads having research experience is a big deal. Undergrads having publications, enough to say that they've discovered something to the extent that it is worth recognizing them in the academic space for their contribution to knowledge, is a really big deal.
Yeah, it is. And so I guess we've kind of talked about, I know you mentioned the PIs, the principal investigators, but they also serve as faculty mentors, right? What role do they play in a researcher's time here?
Right. So I switch back and forth between saying faculty and faculty mentors and PI. So PI, like you said, is principal investigator. They are the ones that are setting the goal of the lab. What is the big question that we want to be pursuing? But then they also are mentoring the other individuals in the lab. So we like to call it an apprenticeship model. So the faculty is usually mentoring grad students, and the grad students are usually mentoring undergrads. Sometimes in small labs, the faculty will directly mentor the undergrads, but the idea being that it takes time and it takes exposure to be able to do something that is so inquiry driven, and when you're on that forefront of the cutting edge of knowledge, that it takes somebody else with experience to help show you the way. And so that's what that process is you as an undergrad are really getting that hands-on mentorship from somebody that has been there. So along with that, faculty, faculty aren't just teachers, and I would even argue that that's not their primary position. So a lot of people, especially first-generation college students, I was a first-generation college student, when you go to college, you just think that the people teaching your classes are there to teach classes. But in reality, most of their job is actually doing research. And so they do teach classes because they are experts in the field. But they are also simultaneously creating this new knowledge and generating new things, like the whitest paint that we talked about at the beginning.
And one of the cool things that I've at least noticed about the Purdue faculty is that while they're extremely dedicated to their research, they're also extremely passionate about the classes that they teach. And I found that most of them, I'm going to say most because you can't say all, there's always going to be a bad egg or two, have been really great professors, and I've learned a lot from being in their classes. It's not that they're just here to do research. They also care about teaching you as the student, whatever class they are instructing on.
Oh, absolutely. Well, and I think that that's really evidenced by Purdue having its own engineering education group. So not only is there this like technical hands-on exploration and research happening, but College of Engineering also has active research in the teaching and learning space. So they're figuring out what is the best way to teach engineers technical skills. And that's why we get undergrads involved in research, because the research shows hands-on is how people learn.
Yeah.
So that's one of the things that I love, is it's really all full circle. The research shows hands-on is important. So therefore, we want to get you hands-on into doing research.
Yep.
And I think on that, a question I'll ask about for undergraduate students is how can they use it like to their advantage in terms of experience and having it on a resume, and why is it good to have research on a resume?
Right. So, well, what I always tell people is research is a career field that a lot have not explored. So I always tell people try it at least once just to see if that's a field that you're interested in. Even if you're not interested in it and you don't actually enjoy the day-to-day, the transferable skills are super impactful. So you know how to identify gaps in knowledge, and then you know how to find them, or how to fill them, I suppose. So it's even if you move on into industry, when you guys are tackling a problem, and especially tackling a problem in teams, then you have the experience of, oh, so here's how research approaches a new problem that doesn't have an answer. Here's what that walk through step by step is. And you can actually lead your teams to be able to utilize these workflows. So it's a very efficient process for finding those new things, which you're always going to run into in the engineering space. You're always building something new. You're always utilizing continuous improvement. And so I think that research and the scientific inquiry process inherently goes hand in hand with engineering design. And so they work together to be able to solve problems, and those are super transferable skills no matter what it is you're doing next.
Yeah.
Yeah. It's always good to get transferable skills no matter where they come from, because they'll benefit you.
Yep.
Yeah, for sure.
And I mean, you can also get like public speaking from going to research conferences, or just presenting to the rest of the group on what you've done for the week. And so there's a lot of great skills that can come right out of doing research.
Yeah, absolutely. Well, and I think that, never mind.
That's all good. All right.
Lost my thought there. Clearly need more caffeine.
No worries. Well, thank you so much, Dr. K, for all of your insights. We've enjoyed you having on this podcast and being able to hear more about Euro. And I guess one last question for you is, what is like one piece of advice you would suggest incoming students have done research, or just in general, about why they should be looking to do research at Purdue?
So for anybody that wants to go into the research space, what I would say, or if they're actively already there, don't be afraid to ask questions. Questions are how we identify gaps. It's how we find opportunities. It's how we learn new things. And so like I said earlier, there is no such thing as a stupid question. That question could be, hey, can I join your research lab? And they might tell you no over and over and over again. But that persistence of asking those questions and not being afraid to maybe look a little silly, that's really what's going to open you up to opportunities as well as learning new things.
Awesome. Well, that concludes this week's episode. As always, please reach out to the Office of Future Engineers with any further questions, or Euro's office. I'm sure they'd be happy to answer any questions you have about undergraduate research here at Purdue.
And yeah, we will see you next time.
Thanks for having me, guys.
Of course.
Yeah, of course. Thank you.